So today, all we're doing today is pretty quick and easy. We're going to look at a group of what we call parent functions. And here's why we're doing this. The next section we're going through is about, really this unit's about graphing. It's not very much algebra at all. Next unit we get into more, we're going to kind of newer algebra stuff where we're going to talk about solving quadratic equations. And so that's pretty algebra heavy. This one is not. It's really just about graphing stuff. And here's our is we want to the most basic types, the most basic versions of a bunch of different types of graphs, and then we're going to make those more complicated by transforming them. Right? You start simple. It's like with a sundae. You start with just the vanilla ice cream, and then you can soup it up any way you want to with all kinds of toppings, right? So we're starting with the plain vanilla functions, and tomorrow we'll talk about how we could take these plain vanilla functions and do some more interesting things with them, okay? So what are they? Well, linear functions. That just means lines, right? So our most basic line would be the function y equals x, or f of x equals x. Okay, so what's that look like as a graph? Pretty easy, right? It's just in slope-intercept form. Everybody agree? In y equals mx plus b form, well, the coefficient of x is what? What's being multiplied by x? Show me with your fingers, everybody. Everybody agree? 1, right? If there's nothing there and it's being multiplied, then it's a 1, right? So the slope is 1. What's the y-intercept? What's the value of b? 0, yeah, because if we're adding something, mx plus b, and the thing that's being added is invisible, well, then it's a 0, right? So that means we've got a y-intercept of 0 and a slope of 1, no big deal, right? Most basic line. Well, what's the domain of that function? What do you think, Johnny? What's the domain of that function? If I extend that, I've got arrows here, so it goes forever in both directions. Yeah, you're going to project it onto the x-axis. We want all the x values that are graphed on that infinite function.
So it'd be like parentheses, infinity, comma, negative infinity.
So flip it around, right? You always have to have the negative on the left, but it'd be all reals, wouldn't it? It's going to look like, well, it's going to look either like that or like that, depending on which, how you want to write it. What's that funny looking R, that double struck capital R that looks like it's got, it's kind of like hollow? That's our symbol for the set of real numbers, but we would more typically write it using interval notation, right? Because again, what does the domain mean? All of the x values. Think about an ant walking on that function. What are all the possible x values that the ant could step on? Well, there's all of them, right? How about the y values? What do you think? All reals, yeah, absolutely. Same thing, isn't it? If we were to project this graph onto the y-axis, it would cover the entire y-axis also, wouldn't it? Okay, end behavior. This is a little different. End behavior. So this is asking us something kind of strange. What does this mean? If we say as x arrow, what do you think that means? Say it again. Transition's a good guess. It's a little bit different in math. What this part right here means is this. This stuff right there, we would read as x approaches. As x approaches infinity. Now, why do we say approaches infinity? Why don't we say as x gets to infinity? Can you get to infinity? No, you can't, can you? Right? It's just, what is infinity? It's not a number. It just means, forever in one direction, without bound or without limit. So as x approaches infinity, f of x approaches blank. Okay, f of x is just a fancy name for what? Y. Yeah, okay, so we're asking as x approaches infinity, what does y approach? Think about the ant that's traveling along this graph. He's going to have to go, in this direction for his x coordinate to approach infinity. Well, while his x is getting infinitely big, what's happening to his y coordinate? It's getting infinitely big. Absolutely. So we get, as x approaches infinity, f of x, or y, approaches infinity. Okay, well, what do you suppose this means? As x approaches negative infinity, point with your arms then horizontally. Which way is the ant traveling if he's approaching negative infinity? Left or right? To the left. Okay, and it so happens he's also going down. But if we just look at that statement right there, as x approaches negative infinity, that's saying that as the ant is traveling infinitely far to the left, what's happening to him vertically? What's happening to his y coordinate? Looks like he's going down. Is that positive or negative y direction? Negative, yeah. So he's going down to negative infinity also, right? So there's the end behavior of that function. Okay. Now, continuous or discontinuous, here's the rule. Here's how you can tell. A function is continuous if I can graph the entire graph without ever picking my pen off the board. So what do you think? Thumbs up, is this continuous? Yeah, it is. It's continuous, you bet. Okay. Moving down. Let's tackle another one. Absolute value. Okay, so here's the parent graph. F of x or y equals the absolute value of x, and it looks like a V, just looks like that, where the vertex is located at the origin. And these points are really important. I want you guys to understand what this thing looks like. So we've got the coordinates 0, 0. Those are the coordinates of the vertex of this V, or the point of the V. And then it's going to go through some other points too. It's going to go over 1 to the right and up 1. So it goes through the point over 1, up 1. And if I go backwards, so if x is negative 1, I also go up by 1. Those are some key points we use to graph this thing. Okay, what do you think the domain is here? Mackenzie, what do you think? Say it again. To infinity. Yep, so all reals. Good. You got it. Negative infinity to infinity. Okay, what about the range, Miranda? That looks a little trickier. It's a little different. That one's not all reals. What's the range going to be? What's the set of y values here? Well, okay, but now I'm talking about the set of all the y values that are contained in that graph. So there's an infinite number of them. Where do they start? What's the bottom y value? 0. Okay, where do they end? Well, do they end at 1? Infinity. They keep going, don't they? Right? So it's going to look like that, isn't it? Everybody see that? We have to have brackets around the 0, though. How come? It's included. Yeah. Okay. End behavior. As x approaches infinity, to SA, f of x approaches what? Infinity, positive infinity, right? As I go to the right forever, I go up forever. Okay? That's what that says. As x approaches infinity, as I go to the right forever, f of x or y approaches infinity. I go up forever. What about the other statement to SA? As x approaches negative infinity, f of x approaches, say it again. No, as x approaches negative infinity, think what that means. If an ant walking on this graph goes to the left forever, where does the graph carry him vertically? It starts here at the origin, maybe, right? Infinity. Yeah, he's going left forever, and while he goes left, he's going up. Okay. And what do you think? Everybody vote. Thumbs up or down. Is it continuous? Absolutely. I can graph that whole thing without picking my pen off the board. So it is continuous. Okay, so again, there's a little, just for your notes, function is continuous if I can graph it without ever picking my pen off the board. Okay, next one, quadratic. Well, there's what a quadratic function looks like. Okay, this is parabolic. It looks like an infinite U kind of, right? So the vertex, again, is at 0, 0. and it goes through the points over 1, up 1, so the point 1, 1, and it goes back 1 and up 1, so it goes through the point negative 1, 1. The domain of this one, what do we think here? Domain of this one. Why don't you guys, what do you think? All reals. There you go. Okay. Domain is all reals. What about the range this time?
0.
Okay, 0 to infinity. Am I including the 0? Yeah, I am. Good. Okay, so it's got to look like that, doesn't it? Okay, everybody good? Okay. End behavior. As x approaches infinity, f of x or y approaches positive infinity, because as we go right forever, we go up forever. Okay. What about as we go left forever? What's going on there? Yeah, it's going up also, isn't it? Everybody see that? Okay, give me 1 to 5 so far. Does that make sense? Okay. All right. Let's see, Abby, thumbs up or down? Continuous? Yeah, it is. Absolutely. I can graph that whole thing without ever picking my pen off the board. Okay. Cubic function, a little different. It's almost like we took the right half of the parabola and just, the left half of the parabola and just flipped it over so it turns down instead of up. It's a little more squared off too, but it's just hard to see. It kind of goes, it's a little steeper and it's a little more severe, I guess. Yep. For the quadratic? There you go. Okay, there you go. Okay, so cubic looks like this. And that would just be f of x equals x cubed. Again, points it goes through. Origin is kind of the important point. It's the most symmetrical point. And then it goes over 1 and up 1 to the right and back 1 and down 1. So point -1, -1 this time instead of -1, +1. What's the domain of this one? All reals. Yep. Okay. Melanie, what's the range, you think? Look at that graph. What are all the y values? Okay, but now those are just specific values. I'm talking about the set of all the possible y values. Well, it does go 0 to infinity, but look at this one. It actually turns down. It looks like it goes down forever too. Well, negative infinity to infinity, right? If I were to project that onto the y-axis, it would cover the entire y-axis, wouldn't it? Everybody get that? If an ant were to walk far enough on this function, he could cross any possible y value because he goes down forever over here and up forever over there, right? Okay, does that make sense? So then we get the range is all reals on this one too, okay? End behavior. As x approaches infinity, Trenton, what does f of x approach? Okay. As x approaches negative infinity, what does f of x approach? Negative infinity. And because we go left forever, carries us down forever, right? Good. Okay. Everybody vote here real quick. Vote with your thumbs. Continuous? Yes, it is. Okay. Square root graph. We got more. Square root graph's a little different. Square root graph actually has a starting point. It starts at the point 0, 0, and that's kind of the end of the line as you travel to the left. From there, it's going to increase, but it increases at kind of a decreasing rate. So it starts steep and flattens out. So it goes through the point 0, 0, it goes through the point 1, 1, and it goes through the point 4, 2, which should make sense if you think about it. X is the input value. So if I input a 4 into this function, well, what's the square root of 4? 2. So the output is 2. Makes sense, doesn't it? Okay. The domain of this one. What do you think, Arson? What's the domain?
Negative, no, 0, the bracket, comma,
Correct. There you go. Good job. 0 to infinity. Okay? Because it starts at 0, but it does include 0. Okay, what's the range going to be this time? Dayton, what do you think?
0 to infinity.
There you go. 0 to infinity. And again, I need a bracket there, don't I? Because it does include the y value 0. Good. End behavior. As x approaches infinity, everybody, what does f of x approach? Infinity, right? As we go to the right forever, we're going up forever. Okay, now this is kind of there really isn't any infinite left end behavior this time. So the left end behavior, as x approaches 0, and we could actually get to 0. We don't even have to treat this as an approaching. Like we could, as we get to 0, what is f of x equal to? 0. Yeah. Okay. Thumbs up or down. Continuous? You betcha. Continuous. Okay. Cube root graph. Just looks like that. You guys are familiar with the cube root. And it's kind of the same type of thing. It looks almost like we just took that square root graph and we just kept going and it sweeps down this time. Goes through the point 0, 0, 1, 1, -1, -1. What's the domain of this one, Johnny? Okay, good. While you're at it, what's the range? All reals, you bet. Give me 1 to 5 on that, everybody. Does that make sense? How the domain and the range are both all reals? Okay. If you're not, ask a question now. Good time to ask a question. End behavior. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Good. And thumbs up or down, continuous? Yes, it is. There you go. Okay, the reciprocal function. Now we get into something that's different. We're getting on kind of stuck in a pattern there. This one's a little different. F of x equals 1 over x. And this time, let's go down to the continuous, discontinuous one to start with. Give me thumbs. Continuous? No, it's not. Look, it's got two different parts. I've got this bottom part, and I have to pick my pen up to draw the top part. So discontinuous. Okay, now this has got some weird behavior here. Look at this one. It's got this, what we call asymptotic behavior. What's an asymptote? An asymptote is a line that a function, the graph of a function approaches but never gets to. And it's like that weird behavior we've talked about before. Like if I'm going to cut my distance to the door in half every second for the rest of eternity, do I ever get to the door? I don't get there, do I? I never actually get there. I keep getting closer and closer and closer, but I never actually get to the door. Okay, that's the same. Yep.
So is it like running a racing car?
Kind of, yeah. I mean, it'd be kind of frustrating, right? Because you just never get to your destination, right? So look what this means then. As the ant is walking along, let's say the right lobe of this function, starting at the point 1, 1. As he moves to the right, his y value is going to keep decreasing and decreasing and decreasing towards a y value of 0, but he never gets there, right? And so we'd say that the function approaches the asymptote y equals 0, which is just the x-axis, but it never gets there. It hugs that asymptote more and more closely, but again, never actually gets there. As the ant starts at the point 1, 1 and moves to the left, as his x value decreases towards an x value of 0, he's going to climb more and more steeply towards the value of x equals 0, but he never gets there. It's like there's an infinite wall there that he can never get to the top of. So that's what we call a vertical asymptote, and that's just the line x equals 0, okay? And then the same thing happens over here, right? So what's bizarre about this is when you're graphing this function, really the most important parts of the function are the horizontal and vertical asymptotes, but they're not really part of the function. They're just there to guide your graphing of the function, okay? So domain, what do you think? Any ideas? Anybody got an idea what the domain should be here then? All reals except what value? 0. Yeah. The one value the ant could never get to horizontally is 0. There's that infinite vertical asymptote that prevents that. So we could say that a couple ways. We could say x is not equal to 0. And if we say x is not equal to 0, then that implies that every other value is okay. If we were going to use interval notation, it'd be a little bit kind of a pain to do, because we'd have to have two separate intervals. Negative infinity up to 0, but with parentheses, right? Because we can't include 0. Or the interval with parentheses 0, comma infinity, right? So why do we have to do it that? Well, because we had to take that one little piece out of the whole negative infinity to infinity. We had to remove 0, which leaves us with that. Well, what's the range going to be then? Same thing, yeah. Same thing. Y is not equal to 0, or using interval notation, we'd have to just write it that awkward way. End behavior. As x approaches infinity, f of x approaches, not this time. As x now look at this graph here. As x approaches infinity, what does the y value approach? No, 0. Yeah, right? As the ant goes infinitely far to the right, the ant gets closer and closer and closer to y equals 0, doesn't it? Okay. Well, how about as x x approaches negative infinity? So as the ant goes infinitely far to the left, that's what I mean to say. What's y approaching? 0. Yeah, same thing. Okay. And what are the asymptotes? Well, there are two asymptotes. We get the vertical asymptote x equals 0, and that's that one. That's this guy right here. And we get the horizontal asymptote y equals 0. Okay? Be good with that? Okay, kind of a weird one. Now, honestly, are we going to do a lot with this stuff this year? Not for a long time, but I want you to get used to these graphs, because you're going to, for the next couple of years, you're going to use these things a lot, right? Even though we're not going to use a lot of these very soon. This is your first exposure to them. And then finally, last page, the exponential function, which we could there's kind of two different versions of this one that we could do. We could either do f of x equals e to the x, or something like f of x equals 2 to the x. In either case, well, what is e? E is kind of like pi. It's called the natural number, and it's an infinitely, it's an irrational number, infinite decimals, never repeats, never terminates. It's what the heck is it? 2.7128, something like that. So it goes on and on and on forever, though. And so that just means, that's a number, right? Just like pi. Exponential functions are kind of the flip of what we've done in the past with quadratics and cubics and things. We've got a constant in the base and an exponent or a variable in the exponent. Sorry. Okay, what are the characteristics of these graphs? Well, they always go through the point 0, 1. And what's their behavior as I go to the left forever? Well, as x approaches negative infinity, what is y approaching? 0. Yeah. Okay. Well, to the right, though, what happens? As x approaches infinity, y approaches infinity. Yeah. And this is the classic. You always hear this, oh man, that thing's growing exponentially. What do we mean when we say something's growing exponentially? A lot. It's growing faster and faster. It's explosive growth, right? What do you notice about this function? It starts off growing slowly, and as you move to the right, it just keeps getting steeper and steeper and steeper, faster and faster, right? So that's an exponential function. What's the domain? All reals. Okay, now careful on the range. What about the range? What do you think? To essay, what's the range on this one? All the y value. There you go. Good. Parentheses 0 infinity. Perfect. Okay. Or y is greater than 0 is the other way we could say that, right? Right. How come we need parentheses? Because of that asymptote, right? It never actually gets down to y equals 0. Continuous. Vote with your thumbs. You bet it's continuous. And asymptotes, yeah, there's one, right? What's the equation of that line if it's the x-axis? Not x. Y equals 0, right? Because it cuts through the y-axis at 0. Okay, and then last one. This is kind of the sort of the opposite of the exponential function. This is one that starts off growing very, very rapidly and just keeps calming down, getting flatter and flatter. It goes through the point 1, 0 instead of 0, 1. And here's the two different versions we could have, something like that. What does this mean? ln means natural log, okay? It just means that the base is e, and log, that's called a common log. It means a base 10 log, but that's not going to mean much to you for now. Doesn't really matter. All you need to know for now is that all the log functions have this basic look, okay? So what's the domain of these log functions then? Okay, 0 to infinity, parentheses or brackets? Parentheses, because we're not including 0. What's the range? All reals. Okay, end behavior. As x approaches infinity, y approaches what, Abby? Infinity. Yep. Good. Arson, as x approaches 0, f of x or y approaches close. I mean, negative infinity. There you go. Vote with your thumbs, continuous or discontinuous. It is continuous. You are correct. And the asymptotes, yes, there is an asymptote. Miranda, what is that? It's a vertical asymptote. Okay, now hold on. Which axis is it cutting through? The x-axis, right? So what is it equals 0? X equals 0. Okay? And then that's it. One little hint. In Desmos, if you want to create a square root, you can just type squirt, SQRT, and it'll just square root. That's a shortcut, keyboard shortcut. And to create a cube root, I don't know how you say that one, Cabert, CBRT, and it'll create a little cube root symbol. Okay. All righty, you guys can work. I'll put the assignment up. It's a really, really quick one. Probably take you about 5 minutes to do, maybe 10. Goes